Welcome, my name is Greg Hogan with the Oklahoma State University Environmental Health and Safety Department. Today we're going to talk about hazard communications. Some of the objectives we're going to be talking about today would be your right to, used to be called right to know, now they want you to understand. We'll talk about the hazcom written program. We'll also talk about the chemical inventory list, or some people refer to them as CILs. We'll also be discussing safety data sheets, your labeling. We'll also be talking about the placarding and labeling requirements. And most importantly is we'll be discussing employee training in the workplace. It's very important to remember this with hazcom. It does inform workers of the hazards associated with the chemicals that they will use. From 2009 to 2016, OSHA cited more than 47,000 instances of hazard violations, hazcom violations in the workplace across the United States. hazcom remains number 2 on the OSHA's top 10 list. And once again, it's most frequently cited compliance standard from 2012 to 2022 with approximately 2,424 violations. hazcom does save approximately 43 people from dying each year, and once again, nearly 585 injuries and illnesses. Because of the decrease in sickness injuries, companies basically have increased their productivity by about $475.2 million and saved approximately $32.2 million with the hazcom program initiated within the workplace. Right to understand, the government, federal government, established the what they call the OSHA hazcom standard or hazard communication standard. It's basically designed to protect employees for use of hazard materials in the workplace. One of the things that it does state in there that companies which produce or use hazardous chemicals or materials must provide employees with information as far as the training, the proper handling, and use of that particular material. The other thing too is, as an employee, you have a right to understand the hazard materials that you will be using in your workplace. And the other thing too is you need to know the potential effects of that particular material upon your health and safety. OSHA's changed its motto slightly. It's just not enough to know. They want you to virtually understand the chemicals that you're working with. That is your right to understand those particular products. There's 5 key elements within a hazcom program. The first one, of course, is employers must have an updated chemical inventory list. The safety data sheets must be available to the employees. The containers must have labels on them. The workers must be trained, and a written hazard communication program shall be established. That's the 5 basic key elements of a hazard communication program. The hazcom program plan basically requires each workplace to have a site-specific hazcom written plan. Laboratories will have what they call a chemical hygiene plan in place, other hazard written program. All employees must review annually at the minimum. All the plans must be reviewed. EHS can provide templates basically for your own free copy of a written hazard communication plan. From an employee standpoint, that is your right to receive a free copy of that particular program. If you are exposed to hazardous chemicals or hazardous substances at the workplace, it is your supervisor's responsibility to once again have you fill out what they call an employee exposure report form. The employee exposure report form is available directly from the supervisor. And that's one thing that is part of the written hazcom plan. Here's an example right here of an employee exposure report form. One of the things that I do want to clarify is that this form is not designed to find fault or blame. What it is designed for, though, is we had an exposure. Where did the exposure occur? How could the exposure have been prevented? Was the employee wearing personal protective equipment? Was personal protective equipment available? The other most important thing to remember is you'll keep a copy of that particular document. You'll also, supervisor keeps a copy. And then the other thing too is send OSU EHS a copy of that particular form. And once again, it'll have the employee signature and also the supervisor's signature on there as well. So From an employee standpoint, that is your right to have the documentation that yes, you were exposed. And once again, where did exposure occur? How did it occur? How could it have been prevented? And most importantly is it does provide you with written documentation. The chemical inventory list chemical inventory list, or CILs, are required from your department and also from each laboratory. The inventories must be available in each laboratory, whether it's in a shop type setting, a storage location. The PIs, the shop supervisors, are required to update the chemical inventory list on campus optics. The other thing too is to start a new chemical inventory list or give someone access, you need to go to ehs.okstate.edu, find your lab safety team page located in the top banner, navigate to the online chemical inventory page for more detailed information. Let's do a little quiz real quickly, see what y'all learned so far. The hazcom standard requires all employers to provide workers with information about the hazard chemicals to which they are exposed. True or false, you think? Well, the answer to that is true. Okay? They are required to provide you with information on the type of chemicals that you're going to be working with. That is from the employer's responsibility. Let's go to labeling. We have two types of labeling systems we use here at Oklahoma State University. The first one is what they call the NFPA, or the National Fire Protection Association Agency, Diamond. And the other part we'll actually be talking about will be what they call the Global Harmonization System, or some people refer to it as the GHS labels. The NFPA Diamond basically was designed for the first responders. This information basically gives the first responders somewhat of an idea of the type of hazards they may encounter if they enter in that particular location. One of the key things to remember, though, is on this NFPA Diamond, they do utilize a color code system. They use a blue. The blue stands for health. The red is for flammability data. The white is for special information. And the yellow is for your activity information. They also use a numerical rating system that runs from 0 to 4. 0 means there's no hazard associated with that particular diamond within that particular diamond area, and a 4 is the worst of the worst. So to simplify that, basically what it comes down to is the higher the number, the worse the hazard is going to be for the emergency response personnel to enter that particular location. The lower the number, the safer that particular area is going to be. The other thing too is on this NFPA Diamond, that information is derived from the chemical inventory list. That's why your chemical inventory list is so important to make sure it's filled out correctly. Is it going to be 100%? Probably not, but at least get it as close as you possibly can, because whatever information is on that chemical inventory list, that's where the NFPA Diamond information is derived from. Let's go on to the next one. Let's back up just for a second here. The NFPA Diamond, okay, where's it going to be located? One of the things that you do want to remember on this part is it'll be located either by the fire alarm panel, or it's going to be located at the main entrance of the door to get directly into that particular building location. And that's why it's very important, once again, to have a good working relationship with the local fire department, because they're the ones actually going to be doing the responding. They need to know exactly where these NFPA diamonds are going to be located, or where do they want them located at in those particular locations. Let's talk about labeling. Labels have 5 important things within the new GHS, or the Global Harmonization Labeling System. Number 1 is we need to know what the name of that particular product is. We need to know the chemical name, the common name. That's one of the things you're going to find on the product identifier. The second part of that particular label is going to have 2 words. It's either going to be a danger or a warning. Danger basically identifies the chemical and products that are present, relatively speaking, a greater or more immediate hazard to the worker. Okay, in other words, it's going to be kind of the bad stuff to kind of work with, once again. The warning identifies chemical and products that are present, that present a lesser, although still potentially harmful, degree of hazard. Okay, so a warning is just a little bit less hazard than what a danger actually would be. Who puts this information on there? That comes directly from the chemical manufacturer for their particular products. They're the ones responsible for creating the labels for their particular products. Section number 3, hazard statement. What kind of harm could the chemical cause? How's this going to affect if you happen to get this particular chemical on you? What's going to be the physical aspect of it? The other thing too is in section number 4, the labels are going to provide you with pictograms. A pictogram, one of the things you want to remember on that, is a universal type of a language. It is a symbol that tells us about the hazards through a picture. Number 5 up there is the precautionary statement. What do you need to do to be safe when you work around this particular chemical? In other words, how are you going to protect yourself? What do you have to have? What kind of setup do you have to have? What kind of personal protective equipment do you need to be wearing? Do you use this particular product in a fume hood? That's going to be in section number 5. When you get all this information put together, this is an example of what the label will look like. And once again, one of the things that you do want to keep in mind with these labels is they're very straightforward as far as what their definitions are. They do break it down very simply as far as what the process is required. And most importantly, it's very legible, so you can virtually look at that particular product and give you a basic understanding of what that particular product hazards may be. Okay, now remember, this is just the label. What's the difference between the NFPA and the Global Harmonization System? What are some of the big differences? I did hit on these a little bit earlier. The NFPA diamond is going to be for your first responders. It's typically located outside of the buildings on doors, or it may be on tanks. It also is visible to emergency responders during a spill or even a fire. Used on secondary and also mixture laboratory containers. You will find the NFPA diamond located there. The second part that you're going to find, what we'll talk about, is what they call the hazcom global harmonization or labels. Okay, these are for workers using the particular chemical under normal working conditions. The other thing too is on safety data sheets and chemical containers, packaging, and laboratory entrances, you're going to find the GH labels located on those particular locations. One thing you do want to remember is do not use the hazcom hazard category numbers as hazard ratings for the NFPA 714 diamond, because the first responders are trained in the NFPA rating system. Big difference. Under the NFPA system, the most dangerous basically is 4. We talked about that earlier. 4 is the worst of the worst. And it can go all the way down to 0, which basically means it has a very minimal hazard associated with that particular product. And that's going to be found on what? Your National Fire Protection Agency system runs from 0 to 4. Higher the number, the worse hazard. Lower the number, the minimal the hazard is going to be. Now, under the GHS system or the Global Harmonization System, the hazard categories runs from 1 to 5. The lower the number, the greater the severity of the hazard. So category 1 hazard are the most dangerous. As you start getting larger in the numbers on the GHS, the hazard becomes minimal. Okay, so once again, that's something that's very important to kind of take note of there as far as the numerical rating systems for both the NFPA and also the GHS. On the outside of the main entrance of the laboratory doors, they're going to have specific placarding information posted there to let the individuals know what are the potential hazards they could encounter if they enter in that particular laboratory space. Post-required PPE. What kind of PPE do I need to wear before I enter this particular location? The other thing too is the GHS pictograms must reflect the current hazards of the laboratory. For some laboratories, the current hazards may change from semester to semester. Some of them may never change. That's why it's very important to make sure that you do have the appropriate documentation or the placarding on outside of the main entrance of the door. The next thing is post the NFPA diamond. The diamond will also be posted on the outside of the main laboratory entrance. Post-emergency notification form, that will be the other portion that is going to be required on the outside of the laboratory area, and all signs must be properly displayed and unobstructed. In other words, what we don't want to see is any type of decorations hanging on the door that's going to visually prevent an individual from being able to recognize the hazards, the PPE requirements before they enter that location. It has to be unobstructed. If you'll notice at the very bottom of the training slide up there, we give you an example of just 4 of the 9 pictograms that you're going to find, and also we provide you the NFPA diamond. So once again, this is going to be basic information you're going to find located where? On the outside of the laboratory entrance door. The chemical storage signage. Once again, if you have storage facilities within your particular laboratory area, the chemical storage signage need to be clearly located. As far as with signage, properly displayed, and once again, unobstructed, should be able to see it. Label areas basically are compatible chemical classes, such as flammables, your organic solvents, your oxidizers or acids. If you will take note on the slide, the flammable storage cabinets, they do have a spring-loaded hinge. That's why it's very important to make sure those cabinet doors are kept closed. When you do remove a chemical out of those, make sure that you close the door afterwards and make sure the door is closed or fastened. And of course, the other cabinets that we have here at Oklahoma State University are what we refer to as the corrosive cabinets. And those are going to be the blue cabinets, and that is essentially what your corrosive materials will go into. Minimal chemical labeling. One thing that you do want to always keep in mind is do not deface or remove the manufacturer's labels from the containers. As long as that manufacturer label is on that container, that will work. All labels shall be written in English. For pure or even purchased chemicals transferred to smaller bottles, make sure you label the new bottle with the chemical name, the common name, and the NFPA or the HMI sticker. In other words, we need to know what's in that particular bottle or that particular container. Anything that is new, synthesized chemicals or chemicals without safety data sheets, we need to know what the name of that is, the HMI sticker, the NFPA signage as well. And the other thing, too, is estimate the hazard values based on similar chemicals. And once again, it's talking about the new synthesized chemicals. In other words, something fairly new that a person may be working with. The dilutions and the mixtures. We want to make sure we have the chemical name, the common name, put the percentage, the molarity of the solution. If the dilutions are concentrated or mixture hazards, please include an NFPA diamond. Either put the percentages or put how many molarity of the solutions been mixed in that particular container. OSHA label peroxide formers. Need to make sure you have the chemical name, the common name, the NFPA HMI label on there as well, the date that it was opened, the expiration date or extended expiration date, and the test date, if any. Notes, dates may have to be added to the manufacturer's label for stock bottles. That's something you may have to actually physically put on there as well. These are what they consider a standardized purchasing guide for OSU, hazcom, placards, and labels. This is just a source that you as a lab personnel or even a shop owner has access to. You can actually go in and seek out additional labels for the products that you actually have in your work environment. Where's a little quiz? Let's go to quiz number 2. See how we're doing so far. One of 2 signal words is required on labels to emphasize the hazard. Which communicates to greater danger? Is it going to be which communicates to greater the hazard? Is it going to be danger or warning? Well, it's going to be the danger. Remember, danger is the worst of the 2 that you're going to find out there on a label. These are what they consider as the Global Harmonization System, or the GHS pictograms. It is a symbol of the hazards of the products. Products can have more than one pictogram on that particular product. One of the things that I want you all to keep in mind is they have three basic characteristics to these pictograms. Number one is the pictogram will have a white background. It'll have a black picture associated with that particular layout. And the other thing too is it's going to have a red marking around the very edge of that particular pictogram. Okay. Let's go to the first pictogram right here. This is the health hazard. Pictogram does show a torso area for that particular pictogram that you see there in front of you. What does it mean now? It could cause cancer, can impact breathing, may once again cause asthma, may cause reproductive problems, even birth defects. The other thing too is it can be very toxic to organs, may damage the person's lungs, and also may be mutagenicity. That's something else that it can actually affect the body as well. The second one you see up here on the screen talks about flammables, two flames inside of one. This could be solid, liquid, or gases. It can also react with other types of substances and actually create a fire. It could burn something on its own by spontaneous combustion. Coming in contact with air, that would be another example where it could burn. So once again, two flames inside of one is an indicator that this particular product is what? Is a flammable type of material. The exclamation point. One of the things that you do want to kind of remember here is the word irritant. Okay, indicates irritant or even some type of skin sensitizers. Can also cause problems with skin, eyes, respiratory systems. In other words, if you get on your skin, it's going to cause some type of problems. It could be a rash, could be a burn, something of that nature. And usually it's going to be what they consider as an acute type of an exposure. In other words, you're going to see something happen in a short period of time with that particular product that you may be using. This is a pictogram for gases that are under pressure. Once again, they may be flammable, may be oxidizing, may be reactive with compressed gases. Accidental release causes cylinder, rocket, or even pinwheel. Those are the pictograms. That's the pictogram for a compressed gas cylinder. The corrosives looks like two vials. Looks like one of them's being spilt on some type of maybe a metal product, and the other vial looks like it's being spilt on the hand. It's going to cause skin burns. It's going to cause damage to the eyes. It can damage the metal or other types of metals. It can actually cause some irritations or some issues there, particularly as far as burns to those particular areas. And of course you got explosives. It looks like a ball with things blowing out of it. Explosive type of material, self-reactive, self-heating. The pyrophorics burns when it comes in contact with air. The organic peroxides, they can burn or even explode. Those are examples of explosives. The oxidizers, if you look at this pictogram right here real carefully, it looks like has a picture of an O with flames coming out of the top of it. The other thing too is oxidizers can cause organic materials to combust. Oxygen, of course, is the most common that you're going to find out there with your oxidizers. Looks like we have a dead tree. We have a fish. That means we're talking about some type of an environmental toxicity. It could harm the plants, harm the animals, impact the water, the air quality. Could also contaminate the soil. These are just some of the examples you're going to find under environmental toxicity with this particular pictogram. And then, of course, the other one that's very important looks like skull crossbones. It's going to cause a severe hazard. Can be fatal. It's going to be extremely what? Toxic. This is what they call acute toxicity. In other words, you're going to see something happen in a short period of time. Essentially, it's what you're going to notice on this particular pictogram right here. A good example where you may run across this one that some of y'all may be familiar with, maybe like maybe a product called Drano. That would be one, or some of the products that you actually use, like decon products will be another one. In other words, in a short term, you're going to see some type of reaction take place, and use that's going to be extremely toxic for that particular product. Got another quiz here, quiz number 3. Which symbols should be used for flammables? We've talked about A, B, and C. We've already covered those, but let's figure out which one's going to be the flammables. We know A is what? The A is going to be the health side of it. That's going to be your health pictogram. Looks like the B is going to be which one? It's going to be your flammables. And C is going to be your acute toxicity. Let's see what they give us here for the answer. It's going to be B. It's going to be flammable. Once again, 2 flames inside of 1. It would be the pictogram you'd be looking for there. What symbol will be used for a carcinogen? Remember, carcinogen is going to happen where? Internally inside the human body. We have the A, which basically may be a choice. We have B up there. And we also have C. Let's see which one this is going to be. This is going to be the A. In other words, it's going to cause some type of an impact internally within the human body. In other words, it's going to affect the individual as far as carcinogens are concerned. What symbol will be used for corrosives? Well, they give us 3 choices here. We've covered all these as well. In case you're wondering, A, that means what? Explosives. B is going to be your oxidizers. And C is going to be which one? Correct. That's going to be your corrosives. Remember the 2 vials I mentioned, spilling on the hands or even spilling on maybe a piece of metal. Going to see some type of a damage occur in those particular locations. Let's talk about safety data sheets. The 29 CFR 1910-1200 G2. Each material safety data sheet shall be in English, though the employer may contain copies of languages as well. Your employer also must have a safety data sheet or an SDS for every hazardous substance you use as part of your job. If you do request a copy of the safety data sheet for a product you use and your employer cannot provide it to you, you may refuse to use that particular product or work in that particular area while it's being used. So in other words, your employer is required to provide you with safety data sheets for the products that you use. If they cannot provide those to you as an employee, you do have a right to refuse to work with that particular product. That's a pretty good part of the 29 CFR 1910-1200 standard that discusses safety data sheets. The safety data sheet is going to have some basic information on them. You say, okay, well, Greg, where does the safety data sheet come from? It comes from the manufacturer. The manufacturer of whatever product you're using is required to provide the safety data sheet for that product. What is the product name? What are the signal words? What's going to be the hazard statement? What kind of pictograms are we going to have for this product? How do you store it? What's the basic first aid? Is this product explosive? Is it flammable? What types of PPE do I need to wear? That's just some of the basic information you're going to find on a safety data sheet. The employee training, EHS HazCom training responsibilities. OSU HazCom program training covers labeling, the safety data sheets, how to get laboratory safety information. Recommend members receive the training every 3 years. The training does not replace your site-specific, laboratory-specific training. You've got to make sure that each year you go back through and do your site-specific training in the laboratory that you do work in. The other thing, too, is if you have any changes within your laboratory, you need to make sure that you do cover it with the employees and make sure it is documented. If it's not documented, it never ever happened. That's one of the things to always remember with any type of training that deals with safety. You've got to have your documentation set in place. The site-specific training is required within the first 30 days of initial assignment, whenever a new chemical is brought into the workplace, and of course on an annual basis. Okay, that all falls underneath which part? Your site-specific training. So in the laboratories, make sure that you are keeping up with, or in your workshop areas, make sure that you are keeping up with your site-specific training, and that's going to cover the type of chemicals that your employees will be working with in that place of employment. So that's where it comes back on the employer to make sure, and the supervisors, to make sure employees are receiving the HazCom training. Training responsibilities include the supervisor, the PI, the principal investigator, the site, the laboratory specific, methods and observations used to detect release of hazardous chemicals in the work area. What are the hazards of the chemicals that I'm going to be using in my work environment? How are you going to protect myself? Are you going to use engineering controls? An example of an engineering control may be as simple as maybe a fume hood. The PPE, what kind of personal protective equipment do I need? Eye, face, hand, respiratory protection are just some examples. Emergency procedures. Those are all the things that need to be covered during the training session. And then some labs, particularly those animal laboratories, may also have other hazards or exposures they need to cover. And once again, it may not be specifically chemicals, but once again, it may be something associated with what is being utilized in these animal laboratory areas. HazCom at OSU. You actually have the right to go in what they call the OSU specific reference OSU policy and procedures. The HazCom program is 3-0535. It was updated back in November of 2015. You can also go into the EHS website at ehs.okstate.edu. You can also find the laboratory safety tab on the top menu bar. Navigate to the hazard communication page. We do give you a link in that particular area as well. It does show up as a PDF. When you do click on it, it's going to look just like this right here. And this essentially is the Hazard Communication Program for Oklahoma State University under policy and procedures. So from an employee standpoint, you do have a right to actually go through this particular document, print it off, and once again, you can have your own personal copy. This is also something that the supervisors should also have on hand within their HazCom program that they have established for their particular work areas. So hopefully this kind of gives you an idea of some of the things that the requirements that we do have out there. Let's go right on back, and we're going to continue right on here. We've talked about the objectives. We've talked about the right to understand. We've talked about the HazCom written plan. We've also discussed the chemical inventory list. We've discussed the safety data sheets. We've talked about the labeling and marking systems. The other thing, too, that we have covered and talked about is the placarding and labeling requirements, not only on outside the main entrance of the door of the laboratory, but also on the door itself, what you have to have before you enter that location. And the other thing, too, is the employee training. We have covered all those objectives during this period of time. Let's go into the next portion real quickly. We've got a little facts. Once again, questions that people a lot of times will bring up during the class time. Can the safety data sheets or SDSs be stored on a computer? And the answer to that is yes, they may. Here's the thing that you do need to remember if you do put them on a computer system, is they have to be readily accessible to the employee anytime that they are in the place of employment. That kind of ties us in with our next question right there. Can I lock the safety data sheets up in a file cabinet? And the answer to that is no. They need to be accessible anytime the employees are in the place of employment. Once again, the readily accessibility is the key word to remember. Another facts that people a lot of times have a question over, are spray bottles required to be labeled? And the answer to that is yes, you need to put a label on a spray bottle. Because here's the thing is, a lot of people, they'll pour a product into a spray bottle. They say, well, I'm going to go ahead and use it right now. And the problem with that is there's always chemical residue still left in that bottle, and nobody knows what's in that particular container. So if you do put chemicals into a spray bottle, you need to identify what that particular chemical is inside that particular container. Put a label on it. That's all that we're asking for there. Does a HazCom training count towards my quarterly safety training? And the answer to that is yes, it does. In the state of Oklahoma, when they passed House Bill 1447, one of the things that they did require the employers of the state of Oklahoma is that they are required to provide employees quarterly training. That means training 4 times a year, and HazCom is one that does count towards that particular training. The next part coming up is just kind of an overview of some of the things that the Oklahoma State University Environmental Health and Safety Department, some of our programs and services that we do offer. We do offer fire protection engineering. We also provide life safety and also emergency preparedness, laboratory safety, occupational health and medical surveillance, materials management, industrial hygiene, the chemical hygiene, and safety training. Those are all things that our department does provide. We also provide with contact information. You can contact any of us. You can contact the Environmental Health and Safety Department at area code 405-744-7241. And when you do make that particular phone call, you can actually specify what questions you may have. And they'll actually put you in contact with the appropriate department for whatever your particular needs or questions are. You can also email us at ehs@okstate.edu. Or you can also come by and visit with us. We are located in University Health Services building, Suite 002. We are located in the basement of the University Health Services Center building. I do thank y'all for listening in for the hazard communication training. Like I say, if y'all have any questions, give us a call. I do thank y'all for your attendance.